Hey guys, here it's Mrs. V. I'm doing the enzyme notes today. So you want to make sure before we get started on the PowerPoint here, you're going to go into Google Classroom here and you're going to make sure that you have opened up the enzyme notes right here and made sure that you have opened up the Google Doc there to take your notes. Here's a copy of the slides that I'll be going through right now, but make sure this is open. Also, you will also notice at the end of the slide presentation, I will take you back through and show you this enzymes reading and questions for you guys to do as homework. So let's go ahead and get started on our PowerPoint, okay? So enzyme notes, okay? That would go on the top for your title. And their essential question today is going to be, what are enzymes made of and what affects their function? So we're going to talk about enzymes and what they do, and then we're also going to talk about what they're made of. So you should be able to answer this essential question at the end of this video. If not, go ahead and go back and do it again. Okay. So cell chemistry. Every biology reaction requires energy. And one of our vocabulary words is going to be activation energy. So everything that happens in your body, to move your hand, your fingers, your toes, to talk, to see, everything requires energy. If you don't have energy, you wouldn't be able to do any of that. So activation energy is defined as the energy required to start a reaction. And it varies depending on the reaction. So how much activation energy you have depends on the reaction. Just like to move, go ahead and hold up your finger and you can move it back and forth. You have so much energy you needed to even get that finger to start, and that's your activation energy. And we'll talk a little bit about how we can change that. So increasing temperature is the easiest way to increase the reaction speed. Couple definitions, and you're going to do this on you've done some of these on your vocabulary, but I just want to kind of remind you, is substrate material. Substrate is material that an enzyme acts on. So the substrate is what the enzyme attaches to. You have products, which is the end material produced by a reaction. So if there's a reaction here, moving my finger would be the product. A reactant is substances that start a reaction. So the energy, maybe some of the stuff from periodic table, which we talked about back in macromolecules. It might take a carbon and a nitrogen, or it might take a glucose. It might take a lipid. Okay, whatever you need to start the reaction. And specificity is enzymes only work on specific substances. So, and we'll talk a little bit towards the end of this one, that every enzyme has a certain substrate that only works with it. And each substrate has one enzyme. So enzymes don't act on multiple different substrates, they act on one. Okay. All right, so this is a graph of a comparison of what we call a catalyzed, which means it has an enzyme, versus an uncatalyzed. So we'll talk more about these definitions, but you can see here's the start of the reaction, okay? And you have to go up this much energy, because this is showing us a graph of energy. You have to go up this much to the top of this hill to be able to get the reaction to occur. So until you get to that top of the hill, until you add that much energy, you can't have the reaction occur. And here, this one, so this top one definitely is an uncatalyzed or no enzyme reaction. The red one has an enzyme. So you can see how much difference it is. So how much lower it needs of energy to start. So it needs much less energy to actually start the reaction and go. So again, this blue one, an uncatalyzed or no enzyme reaction. And here is a catalyzed reaction or a reaction that has an enzyme. In biology, when we're talking about reactions, we're talking about if the catalyst, the only one we'll talk about is enzymes. So when you get into chemistry, you'll talk more about some of the, what we call unorganic catalysts, okay? So enzymes, what are they? So enzymes, since a temperature change is not always possible, enzymes can provide the necessary change to speed up a reaction. So maybe you're doing something and you can't increase your heat or temperature, then that is what comes and the enzyme helps out to start the reaction and get it done. Enzymes, big idea right here, do not provide energy. They only lower the activation energy required. They do not bring energy to the reaction. They simply cause the reaction to need less energy. Enzymes are protein catalysts. So we talked about that other word, catalyst. It's just a vocabulary word that just makes a reaction go faster. And enzymes are the catalysts that are inside your body. And enzymes are made from proteins. So that's why they're a protein catalyst. So all enzymes in your body are pretty much proteins. So enzymes are protein catalysts that bind to the reactants or whatever starts it, carbon, nitrogen, oxygen to start, glucose, lipids, to the reactants and lower the reaction's activation energy so it can happen faster and easier, causing the reaction to occur faster. Okay, so just remember the big ticket out of this one is enzymes are proteins. Okay. Enzymes are temporary. The bond between the enzyme and the substrate is only temporary. So it's once an enzyme bonds to a substrate, it does not stay forever and ever and ever. It can unbind once the reaction is done and it's over, and it can move on to wherever it needs to be. And the other big ticket item here is the enzyme is unchanged. So once an enzyme bonds to a substrate, it does not change it. It does not change its chemistry. It stays the same, and it can unbind and go to another reaction where its help is needed. Enzymes do change the shape of the substrate. So enzymes lower the activation energy by altering the shape of the substrate. So if you can remember, enzymes do not change their shape, do not change anything about themselves, but the substrate does change. And that's how the activation energy gets lowered. I know some of you are going, well, how does that happen? Well, here in biology, we're not going to really explain it. As you go, even in chemistry, won't really explain it. But as you go up, if you decide to go into chemistry, you can actually learn how altering that shape actually lowers the activation energy, what it does. It actually just changes the bonds, okay? So it places a bond on the substrate, which causes the shape to change, okay? You don't need to know any more than that, okay? Enzymes are very specific. Each enzyme will only bond to a select substrate. Though the way to remember this is they fit together like a lock and a key. Your friend's house, the key to their door doesn't fit your door, okay? And your key to your door doesn't fit their door. So an enzyme and substrate are unique to each other, okay? And we're not going to go in the specifics of their names and so forth. I do wish you guys were here in person because we play our card game so you could see the enzymes and some of the substrates, and it's a card game you can play. But the big ticket item here is they fit together like a lock and key. Enzymes are rapid. They will bind to the substrate, catalyze or begin the reaction, and move on to the next reaction very quickly. So enzymes, once they bind to the substrate, they don't stay that way. They will actually, once the reaction is over, leave the substrate and go on to another reaction to help it continue. Now, is it the same reaction? Maybe, maybe not, but it is the same substrate, okay? Enzyme requirements. The requirements for an enzyme is that enzymes will only work in a specific, what we call pH ranges, a certain temperature, and ionic, which is salts like sodium and chloride conditions. And we'll see this in a lab, how when we change things like that, how it can change the enzymes and how they help the reaction work. And any extreme in either of these will denature, what we say denature, or destroy the enzymes. So if you have a really high or low pH, it could totally kill the enzyme. Any high temperatures, a lot of times if you make it too high or too low, it will also kill the temperatures. So there's specific ranges of each of these that enzymes work the best, and if you go in extremes in either way, you could actually kill that enzyme altogether, okay? And when a protein is denatured, is destroyed, it will not work, just like everything else. It's destroyed, it's gone. So energy. Reactions give off or require energy. Activation energy is energy needed for a reaction to begin. And a catalyst is a substrate that speeds up reactions by lowering the activation energy needed. And enzymes are actually biological catalysts made by a cell to speed up chemical reactions in the cell. Enzymes are proteins. This is the biggest idea that you should know. Enzymes are definitely proteins. They are the biological catalysts, and reactions require energy. So this is an example of that lock and key system. So a substrate will have just a certain kind of shape of a place for that enzyme to come in, and only one enzyme will fit, and it fits like a lock and key, and then they become one. Once the reaction is over, this can actually come out, and it can go bind to another substrate. Okay, so that's the end of that. Now we will take a look at our homework for tonight. So you're going to do a little bit of reading tonight on enzymes, and there are some questions. It is a Google Doc. You can go ahead and edit it and then make sure you turn it into this assignment. So we're going to give this a minute. It's kind of loading up on me. Okay. And if you have any questions, please don't hesitate to get a hold of me. So you see you'll have a little bit of reading here. If I can click in here, it's still loading it. But you can have a small amount of reading. It talks about temperature, pH levels, inhibitors. It'll give you a little bit of background on that, okay? Then you'll get down to the bottom, which is your enzyme worksheet. Please read through the reading. It's only 2 pages. You can also annotate that and highlight, underline, okay? And you're going to also then go back through and answer the questions below, and you can just go ahead and type right into those. It's only 8 questions. Also, please make sure, I did forget to remind you, so let's go back and look at that, that when you also, when you have your notes done, make sure you've gone back and done your summary. So you should be not only before you go to your homework, but you should be going back, you should be highlighting, you should be reflecting on anything in your notes, you should be connecting your thinking, going back and seeing what things may be in your life or previous knowledge you can add into that left-hand column. I should see highlights, I should see underlines. And at the very end is when I should see your 3 to 5 sentence summary. So please make sure that you have a 3 to 5 sentence summary at the end of your notes. And once you have completed the summary and you've definitely reflected on everything, I should see highlights and underlines. Attach that to the notes assignment and turn that into me. Then you can go ahead and move on to your homework. If you have any questions, please do not hesitate to get a hold of me. Have a great day.